Hello everyone, welcome to the lecture. Myself Devananda Rao, working as Associate Professor in the Department of CSE, MLR Institute of Technology, Hyderabad. Today's topic is fundamentals of the automata, that is strings, alphabets, language and operations on the language. Automata theory explores abstract machines and the problems that can be solved through computation using these models. To comprehend this domain, it's crucial to grasp the mathematical preliminaries and components utilized in representing machine behavior. Here are some key notations and terminology prevalent in automata theory. So, before getting into details of automata, concept of automata, we need to understand some basic fundamentals, definitions, some basic definitions. So, first we will understand the definitions and the meaning of the definitions with the small examples. First definition is alphabet. An alphabet is a finite non-empty set of symbols which used to represent the input of a machine. So, finite automata needs input. So, that we need to provide input. Here, alphabet is set of symbols which used to represent input for a machine. Alphabets are typically thought of as represented by letters, characters, digits, signs, punctuations, etc. Conventionally, we use symbol capital sigma for an alphabet. Here, alphabet is represented by the symbol capital sigma. It is set of symbols. Set of symbols. The symbols include letters, characters, digits, signs, punctuations, etc. Here, set of letters A, B, set of two symbols or another alphabet 0, 1, set of alphabets 0, set of binary digits 0, 1, sigma, another example for alphabet A, B up to Z, that is set of lowercase letters. These are all examples for alphabet. Common alphabet includes binary alphabet either 0 or 1, sigma is equal to A, B, C up to Z, the set of all lowercase letters, or another set of uppercase letters, all are alphabets. Alphabet is a finite non-empty set of symbols which is used to represent input for the machine. Machine means automata. Next definition, strings. String is also called as a word, is a finite sequence of symbols of an alphabet or sigma. For example, here sigma is 0, 1, alphabet, given alphabet is 0, 1, binary alphabet. String is sequence of symbols taking from sigma. Sequence of symbols, sequence 0, 1, 0, 0, 1, 0, 1, 1, 0. So, sequence of symbols. It is a string. This string is constructed over alphabet sigma, binary alphabet 0, 1. Another alphabet A, B. So, the string may be A, B, B, A, B, B, A is a string. Sequence of symbols. Sequence of symbols is a string. See here A, B, B, A is a valid string from the alphabet sigma is equal to A, B. Another similarly 0, 0, 1, 1, 0, 0, 0, 1, 1 is a valid string from the alphabet sigma is equal to 0, 1. So, string, the definition of the string is, it is also called as a word, is a finite sequence of symbols over an alphabet sigma. Empty string. Every alphabet sigma has a special string called empty string, which means the string with 0 occurrences of symbols. The string represented by this empty string is represented by epsilon or lambda. It is the string that may be chosen from any alphabet whatsoever. For example, if the given alphabet is 0, 1, binary alphabet, see epsilon is an empty string. Empty string is represented by symbol epsilon. What is empty string? Empty string is a string with 0 occurrences of symbols, that is no symbol within the string. So, if the 0 occurrence of symbol, that is called epsilon, epsilon is taking from any alphabet. String that may chosen epsilon, it is a string, epsilon is empty string, the empty string is chosen from any alphabet If epsilon sigma is equal to 0 comma 1, we can take epsilon from that one, because epsilon is empty string. Or if the sigma is AB, so we can get epsilon from sigma AB. Length of a string. The finite occurrence of input symbols from sigma present the length of a string. Finite occurrence of input symbols from sigma present the length of a string. If S is denoting the string over alphabet sigma, then length of a string is represented by mod S. Mod S. If S is a string, length of the string S is mod S. For instance, 001110 is a string from the alphabet sigma is equal to 01, has length 6. Length 6 means 6 occurrences of symbols, 1, 2, 3, 4, 5, 6, 6 occurrences of symbols, that is length is 6. Next, similarly, if the given alphabet is sigma is equal to AB, S is AA, BB, A, BB, B, A, then mod S is 9. So, that is 9 symbols in the sequence string, that is 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 occurrences of symbol. Note, the length of the empty string is 0, that is epsilon is empty string. Empty string means 0 occurrences. The length of the empty string is 0. 0 occurrences of symbols. Next, power of an alphabet. If epsilon is an alphabet, power of an alphabet. If sigma is an alphabet, we can express the set of all strings of a certain length from that alphabet by using an exponential notation. We denoted it sigma power n. Sigma power n. Sigma power n to be the set of strings of length n, each of whose symbols is in given input alphabets sigma. For example, sigma power 0 is equals to epsilon regardless of what alphabet sigma is, that is epsilon is the only string whose length is 0. Power of an alphabet. Here, for example, sigma is equals to 0 comma 1. Sigma is equal to 0 comma 1, that is input alphabet. Sigma power 0 indicates set of strings whose length is 0. Set of strings whose length is 0. So, string with length is 0 is empty string, that is epsilon. Next, sigma power 1. Set of strings whose length is 1 over the input alphabet sigma is equal to 0 comma 1. So, string 0 is length 1, string 1 with length 1. Next, sigma power 2. Set of strings whose length is 2. So, from the given alphabet 0 comma 1, we can give strings whose length is 0, whose length is 2, that is 0, 0, 0, 1, 1, 0, 1, 1. Total 4 strings we got with length 2. That is next, sigma power 3. Set of strings whose length is 3 over the alphabet sigma 0 comma 1. So, the string, each string in the set has length 3, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. 1, 2, 3, 4, 5, 6, 7, 8 strings whose length is 3. Like that, sigma power 4, 0, 0, 0, 0, 0, 0, 0, 1 and so on. Set of strings whose length is 4. Power of an alphabet. If sigma is an alphabet, we can express the set of all strings of a certain length from that alphabet by using an exponential notation. If sigma is equal to 0 comma 1, then sigma power 1 is 0 comma 1. That is, sigma power 1 means length of the string in the set is 1. Similarly, sigma power 2, set of strings whose length is 2. Similarly, sigma power 3, set of strings whose length is 3 and so on. Note, the distinction between sigma and sigma power 1 is crucial. Sigma represents an alphabet wherein its individual members 0 and 1 are considered as symbols. Here, sigma is set of symbols. On the other hand, sigma power 1, sigma power 1 constitutes a set of strings where its members are the strings 0 and 1, each string being of length 1. Here the sigma containing two symbols 0 1, sigma power 1 containing two symbols 0 1, but here these are called symbols, input symbol. Here these are called strings whose length is 1. So that is the difference. This is set of strings, this is set of symbols. Kleene star. Kleene star is a unary operator introduced by Stephen Kleene. It is also called Kleene operator and Kleene closure. It is defined as the set of all possible strings of all possible lengths on alphabet sigma including epsilon. Epsilon means empty string. Kleene closure is represented by sigma star or L star. It is widely used for regular expressions. See, Kleene star is a unary operator introduced by Stephen Kleene. Stephen Kleene. Sigma star, Kleene star is set of all possible strings of all possible lengths on alphabet sigma including epsilon. For example, take this example, sigma is equals to 0, 1. Input alphabet, sigma is equal to 0, 1. Kleene star is sigma star. Sigma star is Kleene star. What is sigma star? Sigma star is sigma power 0 union, sigma power 1 union, sigma power 2 union, sigma power 3 and so on up to infinity. So, sigma power 0, that is power, sigma power 0 indicates set of strings whose length is 1 over the alphabet 0, 1. Set of strings whose length is 0. Set of string whose length is 0 over the alphabet 0, 1. So, set of string whose length is 0 means epsilon. Then sigma power 1. Set of strings whose length is 1, that is 0, 1. Set of string whose length is 2, 0, 0, 0, 1, 1, 0, 1, 1, that's all. Sigma power 3, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1. 1 0 0 1 0 1 1 1 0 1 1 1 and so on, sigma power 3, sigma power 4 and so on. So, sigma power star, sigma star is set of all possible strings of all possible lengths on alphabet sigma including epsilon. So, if you take union of all these, we will get sigma power 0 union, sigma power 1 union and so on. So, set of all strings are possible including epsilon. Set of all strings of all lengths. Kleene plus defined as the set of all possible strings of all possible lengths on alphabet sigma including, not including, excluding epsilon, that is excluding epsilon, empty string. Sigma star is sigma power 0 union, sigma power 1 union, sigma power 2 union and so on. Sigma plus, that is Kleene plus, also called as positive closure, positive closure. Positive closure. Sigma plus is sigma star minus excluding epsilon. Also you can write like this, sigma plus is sigma star minus sigma power 0. Or you can write sigma star is sigma plus union epsilon. Set of all strings of all possible lengths on alphabet sigma excluding epsilon. Epsilon is not there in sigma plus, epsilon also included in sigma star. Concatenation of strings. Concatenation of strings is the technique to merge the symbols of strings together. Let A and B be two strings, then AB denotes the concatenation of A and B. That is, the strings formed by making a copy of A and following it by a copy of B. For example, if A is equals to 1 1 0 0 1 and B is equals to 0 1 0, then the concatenation of strings as follows: AB, A followed by B, that is copy of A, copy of A. What is the string? A string 1 1 0 0 1 followed by B, copy of B 0 1 0. this is concatenation of two strings A and B. You can take BA also. First take copy of B, that is 0 1 0, followed by copy of A 1 1 0 0 1. Concatenating the string. Note, concatenating the string A with the empty string, that is epsilon, it is A only. For example, A into epsilon is A, or epsilon into A is A. That is epsilon into A is equals to A into epsilon is equals to A only. That means there is a string, for example 101. Concatenating with 101 with epsilon is same as 101, or 1 epsilon 01 is also 101, or concatenating any position 101 epsilon is also 101. So, note is concatenating the string A with empty string, that is epsilon, is string A only. For example, A into epsilon, epsilon into A is equals to A only. Language. A language is a set of strings. A set of strings, all of which are chosen from sigma star, where sigma is a particular alphabet called a language. So, language is set of strings which is subset of sigma star. So, we choose, so set of strings, all of which are chosen from sigma star, so that the strings in language, that is subset of sigma star. For example, the language of all strings consisting of n zeros followed by n number of ones for some n greater than or equal to 0. Here n number of zeros, n value is greater than or equals to 0. For example, n is equals to 2. N number of zeros means 2 zeros followed by 2 ones, or if n value is equals to 1, that is 0 1. If n value is equals to 0, that is 0 number of zeros followed by 0 number of ones, that is epsilon. If n value is equals to 4, that is 4 zeros followed by 4 ones. So, the language for this set of strings, the language of all strings consisting of n number of zeros followed by n number of ones for some n value is 1, for n value is greater than or equal to 0 is epsilon 0 1 0 0 1 1 0 0 0 1 1 1 0 0 0 1 1 1, so and so on. Here zeros followed by ones, order is important. Once occur, zeros will disappear, that is after zeros only ones appear. If 1 appears means zeros will disappear. So, first zeros we can read, after ones we can read. Another example, set of strings of zeros and ones with an equal number of each. So, zeros and ones are equal in number, that is 0 followed by 1 is equal, number of zeros and number of ones are equal, 0 1 0 1, number of zeros 2, number of ones 2, so equal number of zeros and ones, 0 0 1 1 1 0, 3 zeros followed by 3 ones, number of zeros and number of ones are equal, 1 0 0 0 1 1 is also equal, number of zeros 3, number of ones 1. But for this example, what is the difference means, in the first example the count, that is number of zeros and number of ones must be equal, as well as order is also important in first question. In the first example, zeros followed by ones in the first example. In the second example, count is important, order is not important. Zeros and ones must be equal in number, but order is not important. That is the difference between first example, second example. A language is a set of strings. See, sigma star is a language for any alphabet sigma. If sigma is input alphabet 0, 1, sigma star is set of all strings of all possible lengths including epsilon, that is epsilon is there, strings with length 1 is there, then strings with length 2 is there, strings with length 3 is there, and so on. So, if sigma is equal to 0 1, sigma star is set of all strings of all possible lengths with including epsilon. So, that language is set of strings, those are chosen from sigma star. Sigma star we can find any string over the alphabet, given alphabet. L is subset of sigma star. Then pi is empty language. Pi is the empty language over any alphabet, that is set with no string. Pi is empty set, that is no string. Then epsilon, the language consisting of only empty string, is also a language. So L is set with empty string, is also a language. But pi is not equal to epsilon. Pi is not equal to epsilon because this is string with zero occurrences. String with zero occurrences of symbols. Empty string. This is empty string. Here pi is null set. Set with no strings. Set, empty set, null set. So pi is not equal to epsilon. Prefix of a string. The string formed by taking any number of symbols from the start of the string. So prefix of a string, for example, W is equals to 0, 1, 1, 1. Prefix for this 0, 1, 1, 1 is, we can taking any number of symbols from the starting of the string. Starting of the string is 0. So I can take 0, or I can take 0, 1, or I can take 0, 1, 1, or I can take 0, 1, 1, 1 prefixes. And also epsilon is also prefix of the string because I already told you epsilon into A into epsilon is A only. So that epsilon 0, 1, 1, 1, epsilon into 0, 1, 1, 1, that is concatenation is also 0, 1, 1. Concatenating epsilon with any string is string itself. So that we can assume that before the 0 there is epsilon. So that epsilon is also prefix. Then proper prefix of a string. Any prefix of the string other than the string itself is called proper prefix. That is, for the same string W is equal to 0, 1, 1, 1, prefixes epsilon, 0, 0, 1, 0, 1, 1. We will take all the prefixes of the string except string itself. So except string itself, all are called proper prefixes. Next, suffix of a string. For example, W is equals to 0, 1, 1, 0. Suffixes means we are taking symbols from the right side of the string. So I will take epsilon is there and 0 and first 0, then 1, 0, then 1, 1, 0, then 0, 1, 1, 0. These are the suffixes of the string W, 0, 1, 1, 0. Proper suffixes of the string. So we will take all the suffixes of the string excluding the string itself. Epsilon, 0, 1, 0, 1, 1, 0. These are the proper suffixes. These are the suffixes. Then substring of a string. A substring is a string is defined as a string formed by taking any number of symbols of the string. For example, W is equals to 0, 1, 2. Substrings are part of the string, that is 0 is a part of the 0, 1, 2 is a substring, or 0, 1 is part of the string 0, 1, 2, or 1, 2 is a part of the string 0, 1, 2, or 0, 1, 2 is a substring of part of the string 0, 1, 2. Okay, these are all the 1 is also a substring. Substring is a string is defined as a string formed by taking any number of symbols of the string. For example, W is equals to 1, 0, 0, 1, 1. Substring is 1, 0 is a substring, 0, 0 is substring, 1, 0, 0 is substring, 0, 0, 1 is a substring, 1, 0, 0, 1 is substring, 1, 0, 0, 1, 1 is also substring. A substring is a string defined as a string formed by taking any number of symbols from the string. Thank you.